Okay. Hola, hola. Okay, I think this is working. Yeah. Can we turn on switch on the lights or? Okay. For me, it's okay. Okay, so let's start with this tutorial about SCANEO for intelligent satellite image labeling. First of all, let me introduce. I'm Fran Martin. I'm product manager at EarthPulse. I'm the product and data lead at EarthPulse. EarthPulse is a startup, a tech startup based in Barcelona. I don't know if the microphone is working, but you can hear me well, right? Yeah? Okay. So EarthPulse is a tech startup based in Barcelona, founded 5 years ago, and we basically what we do is to transform Earth observation data and geospatial data into insights that can be useful for clients. So if you are here, or you know that this data, Earth observation and geospatial data, can be hard to understand, how to process, and make people understand the value of this data is something that it's quite difficult, and we push a lot to make this happen. So I'm in the intersection as product manager. I'm in the intersection between data and clients, so I meet a lot with clients, I speak a lot with them, I try to understand their pain points, and I try to match the data, geospatial data, with their needs to create solutions that they can love and can actually solve these problems they have. So, presentations done. Those are the objectives of this session. So this session is about SCANEO, which is a web app for labeling, intelligent labeling of Earth observation imagery to generate high-quality data sets for tasks such as semantic segmentation, object detection, classification, and so on and so forth. So here we'll demonstrate how we can use SCANEO to, with a small data set, train a model, and then use this model to train itself, reducing labeling errors and optimizing the data set quality. First of all, I like to start with the problem space with some history. So here is Alex. Alex is a Earth observation student, and he wants to label satellite data. He founded a great satellite imagery dataset, and he wants to use this dataset, which is raw imagery, to train an artificial intelligence model. But labeling this data manually can take weeks. So you can think there are datasets with 100,000, even a million of images. So doing this manually can take for very, very long time. So Alex tried drawing polygons and classifying objects by hand, but the process is slow, it's tedious, and is error-prone. So he realizes every time that the model still performs poor. Alex is frustrated with this workflow. But then Alex finds and discovers SCANEO, which is the AI-powered tool for satellite imagery that we are going to see. He selects a small area of interest, generates labels, and trains a model. And thanks to SCANEO, the model suggests the next best samples to label, and the process is faster and more accurate. So Alex can do in hours what it just took weeks to do. And this is what we are going to see in SCANEO in this tutorial. This is the QR to go to the GitHub repository. This is it's hosted in my repository in the FMRIP workshop SCANEO BiDS'25, okay, in case you want to follow this tutorial. I'll wait a bit. In the meantime, how many of you create your own data sets for AI models? And which tools do you use to label this imagery or to create these data sets? How do you draw polygons? Sorry? Yeah, but which tools do you use? Maybe QGIS or? Sorry? See what? Okay, didn't know about this tool. And is this tool designed for geospatial or Earth observation data? So it maintains like the geospatial component of that? So you need to transform then the labels into convert to a geospatial format. Okay. So this is something that we'll see that there are different tools used to annotate images like PNGs or JPG or JPEGs and so on. But SCANEO is specifically designed to cover and to make this happen for Earth observation and geospatial data. Also, before starting, how many of you have attended my EOTDL workshop this morning? I see some of you. Okay. No, I just want to mention that there are some notebooks and some cases that we already seen this morning, but I want to, again, share with the other people as this is relevant to share about and to explain the EOTDL, to fully understand the integration with the EOTDL and the SCANEO and so on. But I hope it will be interesting also. Okay, so let's go to the GitHub repo and let's go to the README. So, as mentioned, this tutorial is designed to guide you participants through the end-to-end process of how to label a model using a SCANEO, how to get a custom data set or a toy data set, label it manually or label it using AI for making the process quick, faster. And then if you want, you follow the tutorial, you'll see how easy it is to use SCANEO, launch SCANEO, and generate these annotations, and the different tools we have across our ecosystem, because it's not just about the SCANEO, which is the labeling tool, but we will also see the EOTDL, which is an open platform to host datasets and models, and we'll see PyTorchio, which is a Python library to train machine learning models using Earth observation datasets. So this is the agenda. This is what we are going to see. So first of all, a brief introduction about SCANEO. We'll see the user interface and the different components. Then we'll see an introduction to the EOTDL, and we'll see how we can explore datasets and models in the EOTDL to then use datasets that we have in the EOTDL and integrate them in SCANEO. And then we'll see how we can ingest the dataset we label using SCANEO into the EOTDL, train a model, and then also ingesting this model in EOTDL. And last but not least, how to contribute, because all of the tools we are going to see are open source. Okay, so you can follow the tutorial in two ways. You can simply watch the live demonstration and run the notebooks later at your own pace. So this repository is open and open to access for everyone in my GitHub. Or you can follow this tutorial interactively in your own machine. So first of all, you need to clone this repository, and then you need to install Python. And for that, as Python package manager, I'm using UV. I don't know if you are used to UV, but it's a new Python package, relatively new Python package, which is very, very fast, much more than pip or conda. And it allows us to, with simply one command, to make sure that we share the same Python environment with the same dependencies and the same versions. Okay? Here we have the commands you can use to install UV in your machine depending on your operating system. So if you are in Mac or in Linux, you can use curl to download the script. Or if your system doesn't have curl, you can use vget. And in Windows, you can use the PowerShell, okay, to install this UV package. You can take a look here. So this is UV. This has been developed by Astral, and as you can see, it's pretty amazing. So it's even 100 times much faster than PIP. So that's why we decided to use it. If not, if you want to prefer, you can continue using PIP. So SCANEO is a Python package. You can use pip install SCANEO to install in your virtual environment. Or if not, if you are using UV, you can run the command UV sync, and it will synchronize the environment, and you have the same dependencies I have in my machine in the project will be installed in your own machine. And then you can open the notebooks in your preferred code editor. Are you installing it? PIP, UV, any troubles with that? No? Can I continue? Any issues installing or? Okay. So let's continue. Before anything, we have a EarthPulse Discord channel, the EarthPulse Discord channel that you can join, where we share updates about the different products we have. This is not like the Discord channel from EOTDL I shared this morning, but this is for the EarthPulse channel. And here we have different channels for different products. One of them is SCANEO, and any updates, news, or whatever we want to share about the SCANEO, you can join this Discord channel, and you can stay up to date about any news from SCANEO. Everything good? Okay. So let's go with the first notebook. So as mentioned, SCANEO, maybe we can make it. Can you see it? Yeah, nice, okay. So SCANEO is a Python package, but it allows us to launch a web application to label this imagery from Sentinel-2 mainly, okay? So as mentioned, it's just a Python package. You can use pip, you can install using pip install SCANEO, or if you are using UV, you can use UV at SCANEO. So under the hood, UV uses pip, so there won't be any conflict there. And now that you have SCANEO installed, depending on if you are using UV or you are using pip, you can run one of the different commands. So if you are using pip, you can simply run from here SCANEO using the exclamation mark, or if not from the CLI. This is if you are using pip, okay? And if you are using UV, you can do UV run, and then you can run or add any command. So you can do UV run SCANEO. And with that, it will launch the local host. Here we can change, there are some parameters we can change. If we do UV run SCANEO help, it will show the different options that we can give to the SCANEO command. So for instance, we can change the port to, by default, is the 8000. You can change the host, you can define the number of workers, and you can print the version of SCANEO. So we are here. So we have SCANEO launch, we can open it. And this is what we will see. Okay, this is the landing page of SCANEO. So what we can do here, first of all, we can see the different features of SCANEO. So as mentioned, and as we'll see before, after, there is an AI-assisted labeling. So we can integrate, if we have a inference API that return mask or return segment classifications and so on and so forth, we can integrate this inference API into SCANEO to assist the labeling. Then we have the campaign management. We can organize your labeling projects with different campaign tools or tracking progress, or maybe you want to have different campaigns for the same data sets, but for different reasons. You can manage it through different campaigns. There are multiple annotation types, so they support for classification, support for object detection, for segmentation, and something that we are developing is the GeoSum. I don't know if you know about this model, the segment anything. Is something we are currently working on to integrate the GeoSum here. So simply adding points, it will be able to segmentate and differentiate across different classes. This is something that we are currently working. Then obviously you can export your campaigns. You can export these labels, or even you can add your own labels if you have them and they are in the SCANEO format. There is support for high resolution imagery. Right now, the format that SCANEO supports is TIFF or GeoTIFF, which is the most common, but we are working again to support more formats. And then we have a plugin ecosystem that we'll see, because we can currently label images that we have on our local machine, but we can also label datasets that are directly stored and hosted in the EOTDL. So, also, as I mentioned, all the tools that we'll see today are open source. So, SCANEO, you can go to the SCANEO GitHub, which is at earthpulse/SCANEO, and here you'll see the source code. So everything you can use and you'll use from SCANEO is open source. You can go there and you can check the code base if you want to create, you find any bug, you find any issue, or you want to contribute to SCANEO, you can come here, you can create new issues, you can see in which task we are currently working on, and so on. Here in the GitHub, we have the same that we've seen before, so a bit of context about why SCANEO. And the main problem here, about the main context to give to SCANEO, is that one of the main barriers for training AI models is the lack of high-quality data sets. So this is a problem that we try to face and we try to solve, democratizing to people the capability to generate data sets in a fast and a quick way. So that's why we develop SCANEO. Also, SCANEO is under the framework of the EOTDL, which I will show later. But this is just to share a bit of context, because there are tools that, for instance, as you mentioned before, that they lack the geospatial component, and that's a problem because then you need to reproject the labels, and there are a lot of intermediate steps. But SCANEO tries to solve this. SCANEO tries to, it's an application specifically designed for Earth observation data. So we want to lower the barrier here. So this is just here in the GitHub. We have the same as we'll see before. So how to install, how to use it, documentation, and some tutorials. What else? Here we can go to the docs, and here we'll have the documentation. This is the same we've seen before. So this is simply a welcome, and this is how to get started using the CLI, and what we'll see using the UI. So this is just a guide in case you want to follow it later. So how to create labeling campaigns, how to match a campaign, how is the labeling interface, how it's exporting the labels we created, how is integrating a model to automatically create labels for your images, and the different integrations. But we are going to see this now in this demo. So the first step should be to start a campaign. Okay, so first of all, let me disable this. Okay. The first thing we need to do is to start a campaign. But to start a campaign, the first thing we need, obviously, is a data set. So we need to create a data set, we need to download a data set, find a data set, or whatever. But we need the imagery first. And this is, at this point, is where the EOTDL jumps in. So let me hit this. So the EOTDL, it's the Earth Observation Training Data Lab, is an open and collaborative platform, which is cloud-based, and it's kind of a centralized repository of datasets and models for Earth observation data. Here, we'll use the EOTDL to quickly get a ready-to-use dataset we have for SCANEO for this workshop with some samples and with some data and some models. But I'd like to introduce a bit more about EOTDL so you can fully understand the full ecosystem of tools that we have. Here we have some questions before going to the EOTDL. The first one I already did about if you are already using a labeling tool. But something I'd like to know is how would it be your ideal labeling tool or tagging tool? How would you imagine it could be? Maybe using some, I don't know, NLP, some chat, some that automatically labels. What do you think? Okay, no problem. We can see later. So everything fine until this point? So are you able to follow the tutorial, the notebook? Have you launched SCANEO? Are you following the demo? Okay. So let's close this. And let's go to the EOTDL. So this is a brief introduction about the EOTDL. So I won't repeat so much, but as mentioned, one of the more limiting factors of AI for E applications is the lack of the scarcity of datasets. We're trying to lower this barrier with the 3 tools that we are going to see in this tutorial. The EOTDL for host and sharing datasets and models, SCANEO to label these datasets and to create the labels and tag it, and then PyTorch, which is a Python library built upon PyTorch to train the models. Okay? So the EOTDL is a project funded by the ESA, by the European Space Agency. This is developed by Earthpulse. We are the project leads. And there are other companies such as EOX, Brockman Consult, Synergize, that maybe you know better from Sentinel Hub, and Space Tech Partners. And this is the ecosystem. Okay, so which are the main functionalities? The main functionalities of the EOTDL is that you have a centralized repository with more than 100 data sets. Some of them are better than others, obviously, because right now the EOTDL doesn't have like an automatic way of creating the data sets. But in case you want to search, as we'll see later, you want to look for data sets for a specific task, you can go there, you can look for models, and so on. We also have the EOTDL is also compliant with Stack. How many of you work with or know what the Stack specification? Yep. Okay. So the EOTDL follows the Stack specification. It has an Stack API, so users can interact with the EOTDL using the Stack API. Then there are some engineering tools to prepare the dataset before labeling it with SCANEO, such as feature engineering, labeling, and so on. And then the EOTDL is accessible through different user interfaces. So we have a graphical interface, which is the web page. We have the API, we have the CLI, and we have the Python library. We will explore how to download and ingest the datasets, and then we'll see how we can download a dataset from the EOTDL and integrate it into the SCANEO. So who is this for? So the EOTDL, as SCANEO and as PyTorch, is available to everyone and free to use. So you might find it interesting if you are a data scientist or you work with machine learning, you are a machine learning engineer working with EOData, and you want to use the EOTDL to share and create datasets and train models, or you are a domain expert and you want to explore the potential of AI for your field, you are a developer, and you want to contribute to the project, or you are a student, as Alex, as we've seen, and you want to learn about AI for EO, you want to jump into this field, and you don't know where to start. So this is the community. This is a separate and different Discord channel as for the SCANEO. For SCANEO is a Discord channel from EarthPulse. This is the Discord channel for the EOTDL. This is managed by ISA. But any new updates from the EOTDL is shared there. Okay. Everything good? Any problem, comments? No? Okay. So, before downloading and staging our dataset to start labeling into SCANEO, I'll show a bit about the EOTDL and the different ways we have to explore and download datasets. Because, as mentioned, SCANEO was developed under the EOTDL framework as well as the PyTorch. So those are the three tools and they create like the AI environment that we are trying to develop to lower the barrier of the democratization of AI for EO. So that's why I wanted to share and explain a bit about the EOTDL, and then we'll go through SCANEO and the different capabilities. So, as mentioned, EOTDL has different layers of accessibility. It has the user interface, it has the API, the CLI, and the Python library. The easiest way to get started with the EOTDL is by exploring the user interface. So it's simply eotdl.com. Here you can sign in, which is important if you want to download the dataset and to follow the tutorial. And to download the SCANEO dataset, you need to sign in here in the main page. What do we have here? First of all, we have some tutorials that we already done for the EOTDL, so LDP Symposium, PhilUp, and the last Big Data from Space from 2023. So you can go there and check the code itself, which is very similar to this one, but this tutorial is the most up-to-date. Then we have the GitHub. So as mentioned, everything is open source. So you can come here, you have the source code, you can check what's the EOTDL, why it was developed, how to install it, different usage examples. So here you can go to a tutorials page, and here we have different folders. So we have notebooks for introducing the EOTDL, exploring and staging datasets, ingesting, downloading datasets, searching for imagery, and so on. So we have a lot of different notebooks here. And also we have different workshops that we've done for EOTDL. Moreover, we have here the issues. So this is how we track the current issues and what we are currently working on. So if you are working with the EOTDL, using the EOTDL, you find anything that could be relevant to add, to comment, or anything you find could be important or worth to share, you can do it using the issue, and we'll take care of them. So here, the most important part, apart from you can explore the landing page. Here we have 2 tutorials. We have the recent datasets, which are the datasets we used and ingested in the workshop of this morning. The most popular datasets, which are the datasets that have most likes, top contributors. Even more, you have models, recent models, popular models, and again, the top contributors. Okay. This is important. If you have feedback, we'd love to hear it. So if you have by any chance, it's a short survey, you have 5 minutes, you can scan the QR and you will through a short survey, and it will help us a lot to improve not only the EOTDL, but also SCANEO and PyTorch. So what can we do here? Now that we are in the EOTDL webpage, we can explore across datasets, models, to tutorials we already seen. Here as applications, we can go there and we can see SCANEO, because SCANEO, we can launch SCANEO in our local machine, or we can also open here. So SCANEO is also deployed here. It's more powerful. Well, it will depend on your machine, but you can deploy SCANEO anywhere. If you have a server, if you have a cloud server, a local server, or whatever, you can deploy SCANEO the same way we deployed here in the EOTDL hub. And it will work exactly the same. So here we have some applications, and here we have the data sets. So we have a lot of different data sets. You can filter by application. You can filter, for instance, for LAN cover, if you want to classify or segment by LAN cover, by data, if you want to check, for instance, using Airbus, SAR data, even vector data, or depending on the task, for image classification or object detection, segmentation. So you can simply go. Let's select this one. And here we have some information. So again, we don't curate the dataset, so it's the responsibility of users to use the dataset to check the dataset quality, to check if it's correct, and so on. But what we can see here is, first of all, some description, some metadata for the dataset, like the brief description, authors, license, source, and the different files that are composed this dataset. So we can go here, and for instance, if we want to download this file, we can go there and we can download it. The point here, the drawback, is that we are going to download it file by file. Then we will see how we can download the full dataset using the CLI or using the Python library. And for models, it's pretty much the same. So here we have ready-to-use models that you can use into your applications. So for instance, if you need a cloud detection model, you can go here, you can select the Cloud Send, and this is simply this file. So you can download this file, and you can integrate it into your workflow, and you can start using this cloud detection model. We'll see how we can integrate this model later in SCANEO to automatically label the clouds, but you can create your own applications using this model. And in case you want to see the source, you can go there, and this is the dataset used to train this model, which it's also hosted in SCANEO. Okay, so this is for datasets, and this is for models using the graphical interface. I won't go too much into workspace because I think it's not relevant for this tutorial. It was just like a quick overview on how to explore datasets and how to explore models. And we can go back to the notebook, and we can do exactly the same, but using the CLI. Before continuing, which platforms or websites do you use to look for datasets? Or when you need to search, or maybe even you don't look for datasets, you only create your own datasets? Sorry? Google? But like you look for simply a keyword, or maybe you look for a repository, or? Okay. And do you find different websites, or do you find different? Did you struggle with that across formats, or? Mm-hmm. Mm-hmm. Okay. So here the point is to actually avoid this and having like a central repository for your datasets. So for Earth observation datasets. So instead of going to Google and struggling with different formats and struggling with where to find it, this is a central repository. This is pushed by ESA, who's pushing to all the datasets developed by them to be there in the UTDL. So the dataset number is growing every day. So there are new users and there are new projects, and every day we hope at least to have more datasets and more models. So Another way of using and exploring datasets is using the CLI, the command line interface. Again, to add the EOTDL, if you are using pip, you simply have to install EOTDL if you are using pip, or if not, you can do uv add EOTDL. So it will be the same. You can do it even uv pip install EOTDL. So as mentioned, the uv is using pip under the hood. So now that we have the EOTDL installed, the Python package, we can go through the different commands. So first of all, we can check for help, and we can see which commands we can use using the EOTDL CLI. So we can check for the EOTDL version, which is the most up-to-date from the 27th of June. We can check the API, we can log in, check for datasets, models, the stack API, and pipelines, which is something that is still experimental. So here, again, if you're using pip, you can do EOTDL instead of uvrun. If you are using pip, you can follow the same, but simply doing EOTDL help. Okay, what we can do now is to explore the datasets command. So this command will help us to ingest datasets. If we have a local dataset, when we want to upload it and share it into the EOTDL, we can use the ingest command. We can retrieve a list of the datasets that are hosted in the EOTDL. We can download a dataset, or we can delete a dataset. So first of all, what you can do is to explore the datasets with the following command, which is, again, EOTDL datasets list. Here, if we add the flag help, it will give some information. So for instance, we can filter by the name, or we can use the limit to limit the number of results. And here, if we do EOTDL dataset list, it will retrieve the full list of datasets that we've seen before in the EOTDL user interface, in the graphical interface. We'll see it here, exactly the same. Obviously, we can filter the search by providing a text string. So for instance, if we do EOTDL datasets list flag and Eurosat, it will search and filter by all of the datasets that has Eurosat in the name. So there are a lot of Eurosat datasets because this is the dataset that we use the most for workshops and tutorials. It's quite a small dataset, and it's quite nice to start working with. Before the first time you run the command, you will be asked to log in, okay? Which will require, as mentioned again, to create an account if you haven't already, but you can also log in using the command uvrun EOTDL auth. In this case, you can log in, or you can log out. So as you can see here, I am logged in with my account. What else you can do? We can, instead of just listing the datasets, we can get them, we can download them. So if we follow the same structure and we use the help command, we can see different options we can use to download datasets. So we can provide a path to download the dataset in a specific path, because if not, it will download to the default directory. We can define a version, and it will download a specific version. If we use the assets flag when downloading the dataset, it will download all the assets of the dataset, because if not, by default, it will just download the metadata of the dataset. And then if we use force, it will download the dataset even if the file already exists. So for instance, if we do EOTDL datasets get Eurosat, I'm going to put a path here. What it will do is to, in this output folder, download the dataset, but not the full dataset, again, but the metadata of the dataset. So here what we can do is to check the README. So here we have some information about the dataset. This is the Eurosat RGB, and we have the source, license, thumbnail, and so on. And here we have the Parquet file, which is a stack packet file created and which lists all of the items in this dataset. So as mentioned, this is something I already did, but by default, all of the datasets are stored and staged in a default folder, but you can change it using the path argument. Even more, UTDL has versioning, which means that if you change the dataset and you add new files or whatever, and you re-ingest the dataset and re-upload it to the UTDL, it will maintain a version it. So for instance, if we go to this dataset, we see that there are different versions. Okay? And here, in version 1, we have these files, and in version 2, we'll have different files. Okay? Here is not loading, but well, just how to show that we can maintain a versioning of the datasets in case you want to go back to another version. You can there is something wrong with you misclick or ingest the dataset or the model into the UTDL. You can go back, recover the work you did, fix it, and upload a new version. Okay. So this is just to show what we've seen, which are the download files. This is the README from the dataset. And here what we can see is the catalog packet, which is the file where all of the files inside this dataset are considered as stack items. So here we have, it's like a stack catalog, which considers that all of the files are stack items. So here we just downloaded the metadata of the dataset, but we can download the full dataset. If we run UTDL datasets, get the name of the dataset, the path, and we use the flag A, with that we'll download all the assets. So if we do that, it will download its data, as we can see, it is staging all the assets. In this case, the Eurosat RGB, it's simply a zip file, as we can see here. So there is not like too much curated, there is not like a structured system of folders, but this is how this dataset is ingested into the UTDL. So as mentioned, we don't do any curation in the UTDL. That's a premium feature that we'll provide in the future. So we as EarthPools take care of your metadata and of your datasets, but this is something that we are planning to provide in the future, not right now. So working with models is pretty much the same at this point. So again, UTDL models help, and the commands will be the same. So you can ingest a model to the UTDL, you can list all of the models that are in the UTDL, you can download a model, or you can delete a model. So if you go through models list help, again, we'll see the same structure because we took care to maintain the same logic across datasets and models to make it the most straightforward as possible. And if we run UTDL models list, we'll have the list of models. Okay, the list of models that we have in the UTDL in the user interface, the same we have here. And to download, it's exactly the same as for models. So here, for instance, if we want to download a road segmentation model, which is already in the UTDL. This is this model, this is pretty easy to use. So it's simply an Onyx model, and actually we'll see later how we can integrate this model into SCANEO. But this is simply a model that is able to extract and segment roads from Sentinel-2 imagery. So here, if we go to data, we'll have this file, the model Onyx, and we can integrate and we can use this model in our workflows. So this is how we use the CLI to explore the datasets and models, but we can do exactly the same from the library. So if we go to the UTDL GitHub, we can see the source code of the library, which is the core of UTDL. So everything we can do with UTDL is here in this Python package. So we have all of the different modules for data access, authentication, curation, models, tools, and so on. And also, we have here the API, which is taking care of everything work. So to ingesting data sets, models, and so on. All of this is done in the API. So you want to take a look on the source code, you can go there. So we can use this Python package to do exactly the same that we did before to see for data sets. So here we can import the retrieve datasets function, and with that we will retrieve the list of datasets. Here we have 101 datasets. Maybe you could see that here in the EOTDL there is a different number of datasets, and this is because I have two private datasets that are not included there. So the one functionality of the EOTDL we won't see here is that you can upload and ingest private datasets and models. So in case you don't want to make them public, you can do that. So that's why we have this mismatch between the number of datasets that we can see here and the number of datasets returned by the notebook, because this is only retrieving public datasets. Obviously, we can filter by name, and we can do some functions here. So for instance, if we want to download a dataset, we can follow the exact same structure before. So we can import the stage dataset function, provide a name, we can say force to make download, we can provide a path, and it will download and stage the model locally. I won't cover this part. Well, this is, I mentioned before, we have the EOTDL is stack compliant. So what it allows us is to retrieve by asset. So in case we have different assets, not just one, as this is the case for this data set, we can select and filter by asset. So we can do different queries. So using this stack API, but this is just to showcase that the EOTDL is stack compliant. So here, for instance, if we check the properties of the asset, we see the checksum, we see the href in the EOTDL API, the size, the timestamp of the ingestion, and so on. And for models, it's pretty much the same. So retrieving, we can get the retrieve models function to retrieve all the models that we have in the EOTDL, and we can import the stage model function from the models module to download the same model that we downloaded before, but using the Python library. So this is pretty much the same, okay? So now that we have introduced the EOTDL, we can go to SCANEO. So let's go to the SCANEO labeling notebook. So as mentioned, now that we understood a bit about the EOTDL and its capabilities, we are going to use a small data set specifically created to showcase the capabilities of SCANEO. So first of all, we need to obviously download this data set. If we want, we can go to the user interface, and if we go there, we can filter by the name. So this is SCANEO. This is the data set specifically made for the EOTDL, and so sorry, for the SCANEO workshop. And this is a toy data set that we can use to have some sample data, some Sentinel-2 imagery, label it, and then ingest it again in the EOTDL. It does not have only same images as we have here, but also it has some models that we'll see later across other models to automatically label the imagery using SCANEO. So now, first of all, we need to download this dataset. So UV run EOTDL models get SCANEO. With this, we are saying that we want the folder in the same root folder. We want all the assets, and we want to force the download. So we are downloading all the assets. I'm going to remove this. No. It can take a bit because some of the models are quite big. But here we'll see that we'll have some samples, some imagery that we can label, and the models. I don't know if it will take so much. Yeah, the most heavy part are the models. But okay, how is it going until this point? Any comments, suggestions? Fine? Yeah, okay. Maybe the internet connection can be a bit slow for this download. I can wait a bit. Are you downloading this dataset or are you following the live demo? Downloading? Okay, we can wait a bit. So I have it in a backup in case it takes too long because the models, as mentioned, are quite big. Well, I think one of them, it's already downloaded. Yeah. Actually, no, we need the other. Yeah, exactly. So it took 1.5 minutes. And here, if we explore, what we have is the README of this data set. So this is a brief description about the models and the sample data, the author, which is Juan Pedro, our CTO, the license, and the source. Here we have the samples, which are some example imagery of Sentinel-2, and we have 2 models. Then after we'll add another model, but for this workshop, we'll use the Sentinel-2 roads model. Okay, so now that we have our data set, let's launch SCANEO, and let's label it. So again, if you're using pip, you can simply run SCANEO, or if you are using UV, you can do UV run SCANEO. Okay, I will go to the terminal because this is open here. We'll close that. And I will launch SCANEO again. And here, now that we have the data set, we can start labeling the data set. Okay? So let's go to campaigns. Let's go to create a new campaign. Here we can provide a name such as SCANEO BiDS'25 workshop, a brief description such as my awesome campaign for SCANEO. Here we can select the storage. So this is under development, so we want to make SCANEO able to connect to your S3 bucket if you have imagery there, so to provide your S3 credentials and so on. But right now, we have the local storage, and we also see how we can connect directly to the EOTDL. So now we can click to the local storage, provide the path, which is SCANEO, because this is here, set the SCANEO folder, and we can create some labels now, but this is optional. So first of all, we can go and we can create a campaign. So this is the user interface of SCANEO. Okay. Obviously, the most important part is the map, the geospatial component. What we can see here? Here, if we click in the show bounding boxes, we'll see that we have different images across this area of interest. Moreover, if we zoom to any place, we can click the reset map to reset to the kind of the centroid of the area of interest. And if we go to samples, here we'll have all of the images that we have in this dummy data set. So we can go one by one. I'll hide that. And we can check them. They are simple images. What we can do now with SCANEO? SCANEO supports 3 types of task labeling. So it supports classification for image classification, object detection, and segmentation. Okay? So let's go, for instance, to this one, and let's create a new label called forest We can go there, can assign a color, and create it. Okay. Something that's important I missed to comment is that here in the settings we can change. We have the different Sentinel-2 bands because right now SCANEO only supports Sentinel-2, but we can play with the different bands if we want to change the visualization. So we can change here the bands, and we'll change the visualization, not only to change the bands, but also the stretch. So here's from 0 to 4,000 to kind of normalize, but we can change it if we want. So what we can do, as mentioned, we can create a first label of classification. So simply by clicking classification, we labeled this image. And if we go to annotations, we'll see that this image have been annotated as forest. So this is simply an image classification. Let's go to another one. We can go for this image. Here we have some buildings. Let's check. Okay. We can go there, and we can say, okay, now I want to detect objects. So for instance, I want to detect buildings. Let's imagine we want to do that. So we can go to detection. We can create another label called buildings. We can provide, maybe a blue color. Now we select the buildings label, and here we choose to draw polygons. So with that, well, I think this color is not very much. Okay, create another label that will do with another color. So for instance, yellow. Here, okay. So here we can see the annotation. So with that we can create by anything. If we want to create, annotate for ship detection, building detection, wind farm, solar panels, whatever, we can use this. And if we go to annotations, we'll see here the labels. Okay, so this is for classification and also for detection. Sorry? As much as you want. So there is like a minimum. You can simply annotate one and export the labels. There is not a minimum. Sorry?
How did you make the detection exactly? You classified first the buildings and then it tried to apply this.
So you mean like the data set and the model?
Maybe I missed it. Maybe that comment, the moment I was looking, but I don't know when you got this detection.
Okay. Yeah. So let's create another, let's use another image. So for instance, I don't know, this one, okay. So here we have the detection, this is the detection button. If you activate it, and then you go to this button here in the top right. Okay. Then, if you select the label, so building, you're going to start drawing. So you first need to activate the rectangle function. And with that, we are annotating. So this is for classification and detection, and we can go also to segmentation. So, for instance, okay, let's see that. We can create a new label, which can be cloud. Let's put a white. And what we can do when we select the segmentation option, we can go there and we can start drawing. So with that, we can modify the size of the pencil. So if we want to make it bigger or smaller. And we can start creating this cloud mask, this cloud segmentation. Obviously now, You can spend as many time as you want here to make the better the labels, the better the model will perform. But we can start here. We can start working there, drawing these clouds. Even more, if we want, we can create another one that could be cloud shadow. No, sorry, I'll delete this one. So we can erase. And if we select cloud shadow, we can start drawing. And we can differentiate the labels by the color. Okay, so this is the manual work. We can classify, we can detect, and we can segmentate. What we can do here, if we want, we can see all the notations, but what we can do here is to export the labels, okay? All of these annotations for all of the images that we created, now we need to export them. So we can go there, export. It says that your annotation will be exported at SCANEO, which is the source folder. You can go there, and you can export the campaign. And if we go back, here we'll see that for every image that we label, we have a GeoJSON with the same name, which contains the labels. So this is simply a GeoJSON with a set of geometries. And if we see for the properties, we'll see here that we have these labels. This is the label, which is building, and here we have the bounding box and the task, which is for detection. So here we have all the labels for buildings. In this case, this is the cloud mask that we just labeled. So if we go again to properties, label cloud, the task is segmentation. Okay, this is like the manual work, the work that no one wants to do. So go image by image and start drawing. Okay, this is if you want to do it or if you need to do it. It's very time consuming, but one of the main feature of SCANEO is the capability to integrate an inference API that can automatically do this job for you. So let's see it. Everything good until this point? Fine? Following? Okay. So, as mentioned, SCANEO has the AI-assisted labeling. So what we need to do first is to deploy. If you have your own inference API, you can use it, you can integrate it. But SCANEO has its own inference API with some models and some endpoints that you can already use, just to showcase how we can integrate SCANEO and the inference API. So first, what we need to do is to clone the SCANEO repository. Here I'm giving a SCANEO API name because if not, it can have some conflict with the SCANEO dataset. So simply git clone here. And here we have the SCANEO. This is the source repository of SCANEO. As mentioned, I name it SCANEO API. And now what we can do is to copy the models from the SCANEO dataset that we have here to the SCANEO API inference folder. Okay, so let's do that with this command. No. Okay, we can take a look on the API before launching it. So this is the Python API, the Python file we are using to serve this inference API. Here we are using FastAPI, but again, you can use your own API or you can use whatever you want. This is just to show you how it works. We'll use this endpoint, the Sentinel-2 routes. It will extract from a Sentinel-2 image, it will extract automatically the roads. But here, the important part is that it needs to return a mask in this specific case, okay? So here, it will apply some inference, it takes the image, it applies some inference using the Sentinel-2 road Onyx file, it opens the model, it creates the mask, and it returns the mask. So this is for this endpoint, which is the Sentinel-2 roads, and also the same for the Sentinel-2 clouds, which is the one that we are going to use. Okay, here I'll put this here in this. Okay. Okay. So now that we took a look on the API and how it looks, what we need to do is to launch the inference API. So for that, here we have the SCANEO API running, and we can go there and type cd SCANEO API and make inference. This will create the environment for the SCANEO application, and here we have the inference API launch in our local host. If we go there and we type docs, it can take a bit to load the first time, but here what we will see is simply the documentation of this inference API. It's taking a bit. Here, exactly. By default, we have these three endpoints. As mentioned, we have the Sentinel-2 roads and the Sentinel-2 clouds. Here we'll improve the documentation, but just to show that this is the OpenAPI specification. So just to show the different endpoints we have here for the inference API. Okay. So now that we have the inference API, we need to activate our model. Okay. So we go back to SCANEO. We go to models. Create a model. We enter a model name. So for instance, Sentinel-2 roads. A description. Roads. And here we need to enter the URL, the endpoint of this model, which in this case, it's localhost Sentinel-2 roads. You can see here. Here we assign the task. We have classification, detection, or segmentation. The segment, anything as mentioned, is still working. But we can say segmentation. Here we have some pre-processing and post-processing options in case we need them. So for instance, to convert Sentinel-2 RGB bands and scale them, and between some values from 0 to 255 or from 0 to 1, and some post-processing options. So depending on your model, you can need these post-processing or pre-processing options. Here we won't select them. So we want to create a model, and we have our model here. Right here, obviously we can use this method, but what we can do to integrate this model into the campaign, we go back to the campaign, we go to manage, and here we can select the model. Something important is that we need to, as this model is to extract and segmentate roads from Sentinel-2 imagery, we need to create the road category. So we are adding here. Here we select the model, Sentinel-2 roads. And something important is that as this model will return a mask with 1 for roads we put 1, and for the other we simply leave it blank. We click save, and that's all. So we can come here, we can go to the campaign, we can go back here and select, I don't know, maybe this one. We select the road label, segmentation, we select the model, and we click the button. Okay, I think I know what's the problem. I move the models here. Okay. Okay. Let's relaunch SCANEO again. Okay, and again, and now yes, because I mismoved the model. So with that, we are using the Sentinel-2 roads model to automatically extract the roads for this dataset. So for instance, if we want to create a dataset for road extraction with just some images, we can train the model and then put this model into our inference API and use the own model to start labeling all of the images. Obviously, it's Sentinel-2, so some roads won't be so well defined because of the resolution, but we can go there and we can go over all of the images and start labeling them. This will start labeling all of the images. And here what we can do, obviously, we can edit the results of the model. So we can go to the brush, and if we want, we can clean it. So we can play with the results from the API. But this is how SCANEO can integrate models that you have to automatically label the images. So this is for road segmentation. We can go there and we can see the annotations. Again, we can export it and we'll have it. So this is for extracting Sentinel-2 roads from Sentinel-2 images. What we can do is to use another model, such as the CloudSend model that we've seen before, to extract and to segment the clouds. So we've seen in some images we have some big clouds, so we can use this CloudSend 1.2 model to automatically detect these clouds. So first of all, what we need is to download the model using, again, the EOTDL, because it is hosted in the EOTDL. So we can do EOTDL models get CloudSend. We have it here. This is just the file, so it's just a small file. And we need to add it to the inference API. Okay, so we have it, the model here in the inference API. Now let's restart. Let's restart the inference API. Go back to the campaign. And we can go through this one, for instance. We can remove the labels we just created for clouds and for cloud shadow. And we need to go again to we need to go first to models that we've seen before. So we need to create cloud masking model. We need to add the URL, which in this case will be the same as before, but changing. Instead of S2 roads, it will be S2 clouds. The task is the same, so we don't need to add any pre-processing or post-processing options. And we create the model. So now we have this cloud masking model. And we have both. We have Sentinel-2 roads and the cloud masking. So we can go back to our campaign, go to segmentation, but sorry, because we need to edit the image. Let's go there, for instance. Up, cloud, segmentation, cloud masking, and more difference. Okay. Okay, let's restart. Yeah. Let's go again, select the cloud label, segmentation, cloud masking, and run model inference. Okay. Maybe there's some bug there. Okay, let's try with that. Go. campaign. Okay. I didn't add the model here, so that's what it wasn't working. So we need to add the cloud masking model and select the one we want to retrieve the information. So we leave everything blank, and for cloud we put 1, and we go to save. Now that it's defined here, we can go there, select the image, cloud, segmentation, and hopefully now it works. Yeah. So the model automatically gets integrated into SCANEO. It automatically labels the clouds. So and again, we can go there, and we can erase it. We can go here, edit the labels. We can spend as much time as we want. And we can export the campaign, and we will have, alongside our images, we'll have all the labels we just created. So this is how we can use SCANEO and integrate an inference API to automatically extract or automatically label the data set. What do you think about this? What do you think about this tool and about this AI-assisted labeling? Do you find it useful? Yeah? Yeah? Sorry? Yeah? So you can integrate other API inference, so any other inference API if you want. So in this case, we are integrating from this API we launched, but if you have your own API and you want to integrate to SCANEO, you can go there and you can create and add your own models. You just simply need to add here the URL. So it's not restricted to EOTDL models. Mm-hmm. So I can hear you so well. So that the cloud masking model, it's yeah. Well, here it depends on the model. So the better the model you integrate with SCANEO, the better results you'll have. So this is just a showcase. Obviously, you need to do some edits and so on, but it was just some showcase. So it's using the Cloud Send dataset, which I think it's quite good. But well, obviously there are always room to improve the models and the results. More comments? Yeah. Do you mean for other tasks such as classification or detection? Mm-hmm. No. So if you have a model that detects forest, you can integrate. So there is no limit here. There is no limit for that. Do you mean at the same time? No, currently it's class per class. Class per class, yeah. So forest or build up or water, it's class per class right now. Any more comments? Yeah.
What would I need to do if I want to use a Sentinel-1 image which was acquired today, for instance? What steps do I need to do?
So right now, SCANEO just have support for Sentinel-2 imagery or for multispectral imagery. But if we find that actually, some users ask for Sentinel-1 support, so probably we'll start working on that, on providing support for Sentinel-1 imagery and labeling.
Oh, sorry, I meant Sentinel-2.
Ah, okay.
But what would I need to do if I want to use an image from today, for instance?
So in this case, you need to download the image.
Yeah.
So,
I can just
and then you can simply go create the campaign, create the path or the folder where you have stored the image, and you can start labeling. So you need the imagery.
I could, with the API, I could create an NRT or a real-time workflow for segmentation of
Hmm.
every incoming Sentinel-1 scene with the model. Would that be possible?
Yeah. So you can, if you want to launch this inference API and use it to automatically detect, it's possible. Yeah, sure. Mhm. Another option that I forgot, I wanted to show, is that we have some plugins. So we can integrate the EOTDL here to label the datasets that are hosted in the EOTDL. So here, for instance, what we need to do is to go to plugins and click enable the EOTDL. We can go there to campaigns. Let's create another campaign. So here what we need to do is to select the EOTDL, and what we can do is to search for a specific data set. So for instance, here we can work with, this is another dummy data set we work a lot with, which is called Boadella. This data set is stored in the EOTDL. So we check here. This is the same data set that we are picking here, okay, the Boadella BiDS'25. We can assign campaign name and some description. And we can create a new label. So for instance, a water label, add it. We won't choose any model. So this will create the campaign. So this will connect with the images and the files that are already hosted in the EOTDL. So here in the EOTDL, we can see that there are different tips in this data set. And we can go through this campaign, and we can see the images. So these images are not local, but are ingested and hosted in the EOTDL. So we can go there. You can create another, I always forgot this. So we can, for instance, if we want to create a water segmentation data set, we can select the water label, segmentation, and start labeling. So obviously this is very quick. And with that, you will label the data set which is in the EOTDL. Okay, so it's another option. This is a plugin to directly integrate the SCANEO with EOTDL without the needs of having your images locally, but in the EOTDL. Another feature in the feature will be to directly label images that you have in your S3 bucket, but this is still work in progress. Okay, I think there is a break now, but the tutorial will take like 15 minutes more, so if you want we can finish or we can come back later. What do you prefer? Finish? Okay. Okay. So, this is about SCANEO. I'll close the API on the launch. What do you think about the user experience? Do you think it's easy to deploy the user interface? Something you like to improve?
I think since auto-labeling is a part of the SCANEO product,
Mm-hmm.
it would be nice, like if I enter some metadata about my data and it can suggest
Mhm.
I think it would be nice.
So maybe searching models in the UTDL and DL integrating them or something more automated.
Yeah.
Okay, that's interesting.
Also, I was wondering, how do you maintain these models? Like, for its performance, do you check its performance regularly, or?
No, so as mentioned, it depends on every user. So any user tracks and maintains the models or datasets they ingest into the EOTDL. So it's it's very difficult to try to standardize the way the UTDL ingests dataset because the formats can be infinite. So any user can use a different format, so it's very difficult to standardize it. So we just create like the stack catalog, and we let the user be responsible. If a user downloads a dataset, is responsible for checking the dataset, the data accuracy, the model itself, and so on. So a lot of models are directly uploaded and ingested from the source. So there is the source, and you can go there and check the performance. But right now there is not like a track monitoring and performance monitoring of the models.
Yeah. I was just thinking, since the user, like after applying the auto segmentation or
Mhm.
algorithms, they can actually go and fix the errors of the model. Like this is a great way to improve the model performance. So if you decide to like host your own models
Mhm.
for this, auto segmentation,
Mhm.
I think it's a nice way to keep the model performance up.
Mhm. Yeah. So the point is that you can have like a small, a small data set, train a model, use the model itself to continue labeling, and then continue training the model. So this is like the flow. Okay, thank you. Okay. So now that we have our data set, we can go and we can ingest it into the EOTDL. So we've seen before, we can download models, we can download datasets, but we can also upload these models or datasets into the EOTDL. So the recommended way, we've seen there are two ways of doing, using the CLI or using the Python library. The easiest way, or the recommended way, is using the CLI. So you can go there, you can run, again, if you're using pip, you can simply do EOTDL datasets ingest, if you are using pip, or if you are using UV, you can do UV run. So with that, what we'll retrieve is the help command for this ingest command. We'll see what we can do. So we can provide the path. It's the same as per model. So the parameters and the options are the same. So in order, obviously, to ingest the data set, we need the folder. So we need the folder containing all of the information. Here we have a SCANEO. If we do a SCANEO sample, we have all of the images with the diffs. A README is mandatory to ingest and upload this dataset or model into the EOTDL. So this is the default README that we have in the dummy dataset, but we can change it. So SCANEO workshop bits. We can create. Here we change the README, as you can see. And now that we have all of the data, the dataset is labeled and so on, we can run UTDL datasets ingest, providing the path. And this is ingesting and uploading all the files, the labels, the images, and so on into the EOTDL. Maybe it can take a while because I think that we have the models there that can be quite big. So it can take a bit. Maybe what we can do is to go to the user interface. We can go there, datasets, and as we see, we already have here the dataset. The dataset we just created with all of the images, with all of the GeoJSONs. It is now hosted and ingested into the EOTDL. So if we do EOTDL dataset list. No, we change the name. We can see that we have loaded and ingested this dataset into the EOTDL. This is as mentioned before, the EOTDL works with a stack, which is combined with the stack specification. So every time the EOTDL ingests a dataset, it creates a catalog Parquet file with all of the stack metadata for all of the items. So for every file, we can go there. We have the README. We have the models. So we have all the files. We have them here in this Parquet catalog. Also, something that I don't want to repeat, but we can work with versioning. So if we want to re-upload, if we do some changes and we want to re-upload this dataset, it will maintain a track of the versioning. And obviously, if we want, we can download. Or again, this SCANEO also this dataset. We can download it and we can play with it, but as we have it locally, it doesn't make more sense. But just to demonstrate that the full pipeline for getting the dataset and ingesting into the EOTDL is working. And the same, we've seen here how to ingest through the CLI. We can do the same through the library. So we can get the ingest dataset function and run ingest dataset, providing a path. We can provide some parameters such as force, but that's all. So we have ingested into the EOTDL the dataset we just created, and we can maintain a track of the versioning, and so on and so forth. Any comments? By default, they are public, but you can make them private if you want. So, for instance, if I go, if here you add the flag PR, it's private. So you can have private datasets and private models if you want. There is currently no limit. You can have as many private datasets and models as you want. Well, okay. Fine at this point? Yep. Okay. Now what we can do is to train machine learning models, and for that I'll introduce the PyTorch library. What we'll do is to train machine learning models using, again, the Eurosat dataset. So, and it's again a combination between the different tools, between SCANEO, between the EOTDL, and between PyTorch. So first of all, what we need to do is let's imagine we want to train a machine learning model with the Eurosat dataset, which is for image classification. Okay? So we can go there. We can stage and download the dataset. This can take a few minutes to download. Well, I think it's a zip file. Here we have the Eurosat RGB dataset. We have the README. We have the zip file, which is the full dataset, and we have the metadata. Now we can unzip it into a train folder, so all of the files inside the zip, all of the images and so on are there. I'm going to clear this. So here we have the different classes for this land use land cover classification dataset, annual crop, forest, and so on. And again, in order to streamline this process, we will use the PyTorch library. So the PyTorch library is another open source tool that we have. So on the one hand, we have EOTDL to host and share the datasets and models. We have SCANEO to label these datasets. And then we have PyTorch, which is a Python library built atop PyTorch to train, specifically designed to train machine learning models for deep learning models for Earth observation. So we can go here. We have the GitHub. Again, all of the code base is open. Here we can see how to install it. Wait for the microphone. Here we have some examples on how we can use PyTorch for training different datasets. So for instance, if we go into examples, there are a lot of different notebooks using different datasets, such as the Big EarthNet, the Eurosat, LandCoverNet, SEN1 flutes, road cementation, and so on. Some tutorials, we have also some tutorials, and some challenges where PyTorch has been used. Okay? As before, if you use PyTorch and you find any bug or anything you want to improve, please feel free to go to issues and add whatever you think it could be relevant for us. So this is not our goal to provide a complete tutorial on how to train the model, but how we can use the EOTDL because this and the PyTorch to train this model. So here we've downloaded the dataset using the EOTDL. And now here, what we're going to do is to use the wrapper, the Eurosat RGB wrapper that is already included in the PyTorch to train this model, okay? So we can go here. Sorry. What's happening? Okay. You need to add the PyTorch package. This is to add using PyUV, or you can simply do pip install PyTorch. So if we run it again, here we have the dataset using for the Eurosat RGB. It's important to mention that here, if we put the download to true, it will re-download the dataset. That's something we already done using the EOTDL, so that's why it is set to false. This can take quite a few minutes, so as we are, it's about 10 minutes left, so if you want, I can go a bit quicker there, or we can wait after the coffee break, whatever you prefer. Okay, here we have. So this is a relatively small data set with 27,000 images. It already separated between training, validation, and test. This is a data frame from the data set. So we have all of the images and which is the label of each of the images. We have the different classes, so classes, forest, highway, industrial, residential, river, sea lake, and so on. And what we can do with this set of code, what we'll do is to simply visualize and plot some images with the labels, so forest, sea lake, residential, river, and so on. And now we create a test and test a simple image classification using PyTorch. So PyTorch right now supports two types of tasks, image classification and image segmentation. We want to add more. But what we can do here is to import the task, the image classification task from the PyTorch package. We create the task. We assign the number of classes. We can see here the shape. And now that the task is defined, we can train the model using Lightning. We import the trainer from Lightning, and here, if you want, you can use, if you have a GPU, you can use the CUDA accelerator in case you have the GPU and you wish to train the model with that. In this case, this is just the CPU, and here you can define the number of epochs, max epochs, train, limited train batches, validation batches. So this will take several minutes. Feel free to follow this if you want, or you can follow it at your own pace. But here what we have is the response. So do we did that I did before. And once the training is complete, what we can do is to evaluate the model on the test set. So we switch the task to evaluation, and here we run some accuracy. So we can see that the test accuracy, it's around 57%. But it's better an image to see the results. So what we can do here is to simply extract a random batch of the model, of the dataset, and see how the model is performing. So here you can see how the model is able to correctly classify the different types of images. So the greens are images which have been correctly classified by annual crop, residential, and so on. And in red, we have the images that have not been correctly classified. So this is a model trained very quick with just one epoch. So obviously the performance can be improved. Now, once we have the model, what we can do is to export it, save it, to later on ingest it into the EOTDL. So you can use the preferred export method. We like to use the Onyx file. So if you want to run this and save the model as Onyx, you need to install the Onyx and Unix runtime packages. And simply with this cell, what it will do is to save this model in this path. So the model we train with the Eurosat RGB dataset will be saved in this model Onyx file. Here, what we are doing simply is to load the model. Now that we have it saved, we are loading it. And again, we are evaluating the performance, which is the same as before, which is more or less around 57%. Okay, so now that we have our model in the Onyx format, which will be, I don't have it here. Okay. Well, we have our model in the Onyx format. What we can do is to ingest it into the EOTDL. So let's go to the last notebook. And this is the same workflow we follow to ingest and upload datasets into the EOTDL. So we can use almost the same parameters and almost the same commands. So the recommended way to ingest a model is using the CLI. So we can do EOTDL models ingest, help to check what we can do, or any specification, specific help, and so on. So for instance, we need the README file containing the name, the author's license, and so on. So now imagine we have the model, we train the model, 10 epochs, or our model is performing awesome, and we want to ingest it in the EOTDL. So we simply create the README file for this model, where is stored the model, the Onyx file. Here I'm just creating this README file with this specification metadata, name, authors, license, source, and a bit of description. And with that, we'll ingest the model into the EOTDL. So we can go to the EOTDL, go here, and this is the model that is trained using this Eurosat dataset. It's ingested here in the EOTDL. So this is how all of the different tools from EOTDL, SCANEO, and PyTorch can interact to cover from dataset creation, labeling, and hosting, and model training. And that's all. So as we've seen before, I don't want to repeat. We can maintain a versioning of the model. So if we change the model, we add new files and so on, the EOTDL will maintain a track of the different versions. We can have as many versions as we want. It's the same as if you work with Git. And here, you can download this model. So you can use run EOTDL models, get Eurosat RGB. Here, if we use the F flag, it will download. It will force download. So in case the model already exists in the file directory, it will force the download. Here we are specifying the version. Here we can check that the model actually exists, and we can do the same. We can ingest the model through the Python library. So we import the ingest model function, we specify the path, and that's all. So yeah, so that's everything I wanted to cover. So this is the last notebook, just in case you want to get involved. As mentioned, all of the sources and all of the tools we've been seeing are open source, EOTDL, SCANEO, and PyTorchio. So if you want to contribute to the code base, if you want to add new data sets, new models, if you find some bug, whatever you want to simply contribute, please feel free. This is the Discord server of EarthPulse and SCANEO and PyTorchio, which is also maintained by us. And yeah, so that's all from this tutorial. Thank you so much for attending. I think it was a short one, but I hope it was interesting it was more specific about the SCANEO and how to label automatically. I think that the idea you provided to use the inference API is a very nice idea. So it's something we didn't realize, but maybe we can go through it. And also your feedback, it's also very, very nice. So we obviously are continually trying to improve the product, but based on your feedback. So we don't want to create new features that anyone won't use. So that's why we want to hear from you. So if you want to contact us or you want to add anything to GitHub, please feel free. So we'll really appreciate it. So, yeah, that's everything. Yep. Thank you. For the pipeline, you mean in the EOTDL?
For the SCANEO, SAM integration.
Yeah. I think by the end of this year. So in this quarter, I think this will be integrated. That's something that we used to have, but the model changed and we need to readjust. But it won't take, so it will finish by the end of this year. So if you want, you can stay in touch with us, join the Discord, or send an email to us if you want to try. Cool. Hi.
Change batteries for
I finish, so it's
so it's over.
yeah.
At all?
Yeah.
Oh, okay, okay. Very good.